you know. If it's a long code, then we won't be able to do it, right? Hello? Am I audible?
Yeah, yeah.
Hello?
Yes, yes, you are audible. Yeah.
So suddenly, Afnan, why did you stop it?
No, no, just asking about whether we are going to discuss theory only or will it be coding also? That's
A little bit of coding also, if it is
okay.
small
Sure,
and if it's required.
sure, sure. Yeah.
All right. So, so we didn't do this KMP algorithm yesterday, right, Uma? We did
Yeah,
not
yeah,
do this.
yeah. We
So
didn't.
we'll explore what this KMP algorithm. Does anyone know how it is done? What KMP algorithm is? Hmm. Okay. So there were, I mean, few people were absent yesterday. Vikram, Subramanyam, Afnan. Like,
Yeah.
how are you
I
guys?
was busy in the project submission for application development and all, so not able to
So
attend
yeah,
that.
I mean, I'm just asking you, how good are you guys with the previous concepts? I don't know.
So the last 3 or 4 weeks I'll have to revise. So I'm not very through with them because of the other subjects that were going on. So
Hmm.
in pdsa I was not able to very much focus on the
Okay.
last weeks. Yeah.
Hmm. Okay, fine. What about Subramanyam and Vikram?
I didn't follow the question. What was the question?
So how good are you in this week? Like we were doing the first half, wherein we covered Boyer-Moore, Ravencorp, and yeah, the native search algorithm. So
Yeah,
I'm just asking you, how are you with Ravencorp and the Boyer-Moore? Do you know the theory beyond that? I mean, behind that?
theory part I got it, but I didn't really pay much attention on the coding part.
Okay. So Vikram, what about you?
I have no idea. Seeing this
Oh my
first
God.
time.
Okay, okay. So I'll just give you an idea of it, just an idea. Okay. So Vikram, I want you to follow. Okay. So this is the original text. Okay, Vikram.
Okay, yeah,
So
got it.
given the text, yeah, and we are giving a pattern, and we are just getting out, uh, the position, the index where the pattern is starting.
Okay,
See, at the zeroth index, you have ABC pattern, right? If you start at zero, you will have a pattern, and similarly, they are saying that if you start at index 7, you will have a ABC pattern.
okay, got it.
Okay, so that is what the input and output is. So that is the same here also. Okay, for the Rabin code. Okay,
Okay.
and there is some other thing which you need to know, but let's move forward. Okay, it will take too much time, so we'll continue with where we left. Okay. Okay, fine. So we have the KMP algorithm. What does it say? So it's basically KMP fail. They call it as KMP fail. Hi Nikhil. Hi Balaji.
Hello.
Yeah, yeah.
I
So can someone tell about this? What is this KMP algorithm? Right? If no one knows, then just like yesterday, we'll just watch a little bit of the lecture and come. Uma, what do you say?
Ravina, I don't know. Speak up means only if I know I can speak. Yeah, Gokul, that's better. I watched on YouTube, so actually these week 10 is everything so close to each other. That's why I'm not exactly remembering.
That's correct. So I'm just asking you guys like just a start. I just need the start of it. Nothing else.
Just know the name. What is Snow Rat and Morrison development, right? Yeah, that's right. What is that written on the top? No.
This
Okay,
has
repeat.
something else, a little more detail. I couldn't express Gokul. There is, you have to write the pattern, some numbering we will give it, like a pi table. I remember watching only on YouTube. So
Okay.
actually, in this, the main thing is the I won't come back. It will go move forward, but the pattern thing, something will go back in. I see series. I'm not very clear. We can go and watch the lecture.
Yeah. You want to watch the lecture or some other video, external video?
Whichever is comfortable. We can even go to the slides or something.
No,
Whatever
it's
is.
better to go with the lecture
Yeah.
only.
So we will now look at the Knuth-Morris-Pratt algorithm for string matching. So what we said last time was that if we can pre-process our string into this automaton which remembers the longest prefix match at every stage. So if I have a prefix match up to a particular letter, and if I read a letter, what will be the new prefix that matches?
Okay. So can someone tell about this automaton from yesterday? Guys? Balaji, Nikhil, if you guys know. Subramanyam, you want to say something?
No.
Okay. So look at this. So we have the pattern here. So which is A B A B A B A C. Okay. So A B A B A C. So we are like this is a kind of a graph. Okay. So which will tell us the prefix. Okay. We'll move forward and I'll let you know how this is coming up. Okay.
So if we have such an automaton, right, the state I denotes the match up to P of I, and the transition tells us how this match gets updated if I read a letter A at I. Then we can do this in one scan of our text by starting at the initial state, following this automaton letter by letter, and seeing if we reach the final state or not.
Okay. So I want to tell something here. Uma, this is the graph that we are given. Okay.
Yesterday I was confused because that fight we are going back. No, I was not clear yesterday. That's why.
Yeah, maybe that diagram was wrong. I think I'm not sure though. But
Oh,
we will have always only one path. See, you can see this the lecture here. See this everywhere. It is just one thing, right?
yeah.
You won't have a different. So let's say you want to process this part A B A B A B A C, and you're having this automaton. Like this is some kind of what some kind of table or something logarithmic table we have in our max, right? Easily to compute the data. So somewhat we are having this structure. Okay. So who can help me here? Subramanyam, can you? Yeah, Nikhil, you want to follow with me?
No, what help do you need here?
No, I just want you to know how the bottom part is coming. The number
So,
at the bottom.
so the horizontal sequence that we are seeing 0, 1, 2, 3, 4, 5, 6, and the straight arrows, we are going by that line A, B, A, B, A.
Mhm.
Suppose we get suppose we are at 4 and we have passed A, B, A, B. Then at
A
fifth
B once again, once again. A B. We are past A B, and
A, B.
we are at
And
4.
yeah, and at fifth position, if we see B,
Correct.
actually it is A. At fifth position, it is A. But if we get B, then we will go back to 4. Means we have matched A, B, A, B. So we are still matching A, B, A, B. And if we get A, that bottom arrow, if we get A, then we go back to the position 1. Means we
Correct.
have only matched A.
Hmm.
Mm, That's how this graph, your automata is working.
Correct. Exactly. Uh, okay. Afan, have you seen this already?
Yeah, this lecture, no. I've not seen it yet.
No.
Yeah.
Okay, but this automaton, what happens is, see, you have the string A B, like this is the path, this is the
Okay.
text you are trying to
Yeah,
process.
input.
Okay.
This is the
Correct.
input, right?
Input text, and this is kind of the output.
Okay.
Okay. At the given position, where the pointer is something like that. Okay.
Okay.
See, you start with 0 and you see a, right? So
Sure.
you're at 0, and if you see an A, the arrow A will make you to go to 1.
Okay.
See, from 0 to 1 you're going because of A, right? So then you have a B. From 1, where will the B arrow take you to? It will take you to 2. You're following what
So,
I'm saying?
okay, but why is it that we are following on this pattern? Because that itself is the input, no? Because we are not talking about the pattern yet, I believe.
No, the
What do you mean?
pattern is A, B, A, B, D, A, B, C, but we are matching what yeah, we are. These are our inputs. That text we are matching A, B, A, B, A. And if the
Ah,
text differs at any certain point, if it differs, then what are the text will be differing? So we take that text and we go backwards to the arrow. That text takes us to the position backwards. If we get B instead of A, if we get B at 5 position, we go back to 4. Instead of A, uh, if we get
Correct.
A at 5 position, then we go back to 1. That's how it is working.
So, Afnan, if you want to come to how did we get this graph? I mean, it was covered in the previous, but if we go there, it will be too much. All that I want you to understand is how we get this processing. Okay,
Yeah, okay.
Afnan? Okay. So if you see 0, 1, 2, 3, 4, like it's A B A B C, A B A B, and you're at A, right? A B A B, and you're at A. After this A, you're getting a B. So until this point, you're coming straightly, right? A, B, A, B, and A. So until the first five characters, you're following a straight path. Am I right, Afnan?
Yeah.
Okay. So after this, you're in the text you're having a B, which means B is taking you to the previous value. So you're going to 4. That's what they are saying here. See, after 5, you go to 4. Okay. Then here again, if you are seeing a, you're again moving forward. So 4 to 5, and then finally you're having a C. So what this denotes is basically you don't need to compute again from the scratch. So you're making sure that you know where the prefix is located. How much of the prefix of the prefix of the pattern has already been matched. So it will be a little bit hard to understand, but let's proceed further. If you have any, does anyone have any doubts? So the more doubts you ask, then only I'll be able to clear it.
I think at this stage is more abstract. As we start working through some examples for
My
it,
doubt with Nikhil or Gokul, actually a pattern is found as AB, right? Again the same pattern. At that point, why are we not going back? That's where I'm getting confused.
What point?
Oma, which
No,
point?
we got AB first, then again the same pattern is repeating, right? Why can't we go back at that stage also? Because the same letters are coming again, right?
The
Which
same
position you
letters
are
are
seeing?
matching with the third position. Now, look at position 5. Okay, at position 5, if we get 6, we move forward to 6. If we get B, we move backward to A. If we get A, we move backward to 1. The, the letter at position 5 that we get will decide if we are going to 6 or going to 4 or going to 1. We don't know what letter we are getting. Na?
Okay.
at 4 you have both the if you forward pass you get A. From B you are getting the backward path B is there, no? How to resolve that? You got my question? From the node 4,
Huh?
Mm-hmm.
on the straight path you are getting A.
So
Correct.
you are going to 5.
No, let me finish it.
Yeah.
Then at the same time, from 4 you are going on the reverse path B.
No. You didn't get it. At 4, if we get A, then we are going to 5. If we would have got B, then we would have got to 0. But we are getting A, so we are moving forward to 5. A, B, A, B, A. Look,
Okay.
Actually, can you help with one thing? Suppose for a particular position, third position, say
Yeah.
what is a prefix and what is a suffix? So then I think we can able to visualize it. Suppose A, B, A, B. So now
yeah.
fourth, we are in a fourth place. Say A, B and A, B. So this fourth place B I am having. So for that B, what I am supposed to do? Prefix, which prefix has matched with which suffix?
If prefix AB has been matched up to the fourth place, if you are at fourth place, then prefix AB has been matched. If at fourth place we get B, then the B will not be matching with A. Look at the fourth place there is a A, so B will not be matching. So we move back. We have to start from the scratch because any prefix would not be matching then.
Nikhil, may I take this?
Yes.
Okay. So Balaji, you are asking the question, right?
Yeah.
Balaji? Yeah. So what
Yes,
was the
yes.
question again? Yeah, what was the question again?
say I am same. I am at the fourth place. A B
Correct.
A B.
You're at fourth position. Okay, great.
So for that,
Okay.
what is the prefix and what is the suffix I have to search for or I have to pattern for?
No,
So
you
in
don't
that
need to search
one,
for a prefix or a suffix. Like, see, all that you need to do is, see, you are given a text here. So this is some kind of a map for the pattern that you're searching. Okay. Repeat what I told. This is a map for the pattern that you're trying to match.
okay,
Okay. So if suppose, see, in this case, you are only having A, B, and C. Three different things are there. Okay. So let's take an example text. Okay. So A, B, B, A, B, B, A, something like this. Okay. So now we'll try to do the processing. Okay, processing. So what happens? So you initially start with zeroth index, I mean zeroth position. So you find A, right? So from 0, you go to
Excuse me. Are
1.
you writing down something?
Isn't my screen visible? Oh my god, I am sharing just the
Yeah.
tab. Huh?
It's just the.
Oh, sorry. Okay, so wait, hold on. I'll share it. Thanks, Afran. Yeah. So, yeah, Balaji?
yes, yes.
Yeah, are you able to see this?
I'm in.
Yeah. See, this is the text we are trying to process. Okay, and we are trying to see if we are trying to if you're having any match or something. Okay, Balaji, following?
Okay, following.
Hmm? So if you're at A, so if you're starting here, you find the A, right? So if you are having A,
Right.
you move to position 1. Correct.
Okay,
So then you find
okay,
B. That means you move to position 2.
okay,
All right. So then you find B again. So which means BB is not a pattern at all in this the whole pattern, right? You don't have a BB continuously.
yes,
So which means this BB is collapsing the whole prefix of the pattern.
okay,
Correct. So you go back to the start. That's what it's saying. So you're at question 2. You go back to the start. So nothing has been matched. You
okay,
start from the scratch again. So if you're having a B again, see, you do a loop again because B is not the first starting of the pattern. Correct. Now you have
okay,
processed A, B, B, B. Okay. So after that, again from this starting index, you go to A. See, I mean A means like 1. Okay. Then you're getting a B again, right? Hello.
okay.
Now where will you go?
Yes.
Can you tell me? So
Our pattern is A B B B, no?
correct.
Our
You're at
A B.
this position. Okay. You have covered this, and then you're at this index. Okay. At this position, if you're finding a B, I mean next position is B. Next arrow
Then
is
we are
B.
in a zero only.
Correct. We will go to 0. Okay. Then after that 0, what do you find? You're getting an A. That means how much at the total after processing the
1.
string? Yeah, you're finally at the position 1. That's what the whole thing is. You kind of
See.
understand something here?
Yeah, that's fine. I
Oh,
understood. But
okay.
I could not able to relate with this with the KMP or so. I don't.
Yeah, we'll go there. We'll go there. Don't worry. That's what they are saying here.
Okay.
Okay.
Just one doubt. So matching
Yeah,
this text with that processing pattern, right?
repeat.
How are you going back? Matching with that AB, AB, BAC?
Correct. Yeah. You want me to repeat it? Can you tell me? How are you
Maybe
going back?
one
Is
time.
there what your question?
Yeah.
No, it is just like a flow chart. We have to just go.
Exactly.
That's it.
No,
Oh,
Gokul, can
Uma.
you repeat again?
No, I want to know your how much you understand. So you can tell. So whenever you are getting stuck, I'll tell you.
I'll just,
Tell me how much you understood.
I could go comfortably to AB. After that, I'm not
Okay.
able to really connect the flow and the mapping.
Sure. Okay. Let's do the same thing. Okay. So from 0 to A, you are going right.
Yeah.
Correct. So you have processed A. So at this point, from here you're going to. I mean, next is B, right? So from here you're going to B.
Right.
You understand what is happening? Yeah. So we have processed B. next you're at this point and you're having an arrow to, I mean, next is B. So you should follow the flow chart, I mean, the path to B. I mean, the way the B, what do you call it? B edge is taking you to. Here it is taking you to 0.
Yeah.
Subramanya, follow this much?
Yeah.
Okay.
No.
Great. Okay.
This is where I get confused now.
Okay.
We have node 2. We have an option of going forward and going backward. So what
What do you
decides?
mean by? See, you're at this position, right?
Right.
Okay, which means you have covered AB. Okay.
AB
So,
covered.
okay, now next letter is B.
All right. Yeah, I have B here, but
Correct.
in the flow chart I have an option for both A and B.
Correct.
So
So
what?
if you have a B, you should follow the B path.
Okay.
Okay,
Okay,
you follow the
the
B.
graph is given. Is that the correct thing? We are not drawing the graph.
Correct. We are
Yes, the
not
graph
drawing
is
the graph.
given.
That is where
The
the
graph is given.
the graph is given and we are comparing with the graph.
Yes,
Okay, that was not okay. I got it now. Oh, I thought we are drawing the graph.
No.
No.
So what is the problem statement now? What are we really doing?
Okay.
This is hello.
Go ahead, Nikhil, please.
The KMP algorithm is all about drawing this automata in log n time.
No.
This
Now the
automata
question here is why do we need this diagram, Nikhil? Why do we need this diagram?
Yes.
That's the question.
to match the pattern, na?
Correct. And what's the advantage of this? How I mean, anyway, I can match the pattern. What is the advantage of having this automaton?
Because you are matching the pattern in one pass of the string. You are never going backwards. A B A, you are going just forward. You are not going backwards in the string.
You don't have to, go back. That's what you're saying, right?
Yeah.
Okay.
In log n time, you will match the pattern, match anything.
Okay. So
Once
let's come
you have
to.
automata, that's it.
Yes. I get the point. Okay. So Subramanyam, coming to your point. Okay. We have the text which is equal to AAB. Okay. And the pattern, or let me take it like ABC A.
ABC.
Yeah, I'm trying to do something. One second. ABC. Okay. So this is the text that we are having. Okay.
Okay.
And the pattern that I need to match is ABCD.
Okay.
Okay. So how will we compare this? See, first you will compare A and A, which is matching,
Yeah.
right? B and B, which is matching. C and C, which is matching. Then you see an A and D, which means it is not matching, right? So what do you do next? So you will start from here and take these 4 and process. Usually the brute force method is that, right? Correct?
No.
By brute force, repeat.
I mean, not correct, because A, B, C, D is not there, but still by brute force we are ignoring the requirement for D and just forcing the A.
Yeah, which means the first 4 pattern, first 4, the first 4 letters are not a pattern match, right?
Yes.
Then we go with the next. I mean, not the next one. Leave the first element and take the next 4. Right? So if not matching, then you do the you come back again and again, do this like so many number of times, right?
Okay.
So look at how many number of comparisons you need to do for this. See, I had taken some random text and pattern, but there are some worst case algorithms, worst case patterns and stuff like that, right?
Okay.
So
here in this case, nothing is matching, no?
Yeah, nothing is matching. Okay.
Yeah.
So A B, something like this. Okay. If I have A B, see, look at this. A and A match, and B is not matching. So again, you need to go start from here and try to see this, right? Again next to 3. So this is how you generally by brute force you do it. Okay, if you have this automaton,
Okay.
what this automaton does is basically it kind of pre-process, do the pre-process for the pattern.
Mm-hmm.
Okay, so they are
Then
saying that
we don't.
correct. We don't need to come back again from
We
the
don't.
scratch. You just need to go in a single flow.
Okay. Okay.
Nikhil, was I correct or am I wrong?
I did not hear. I did not hear this.
Okay,
I
okay,
was
fine, no problem.
typing. I was typing some reply.
It's okay, it's okay, it's okay. I understand. Okay, so that's the point, Subramaniam. Hmm?
Yeah, I got it. I'm with you now.
Okay.
Okay.
Mm-hmm.
So
So
Gokul,
this,
in the exam, this graph will be given and we have to go with the graph, that's all, right?
correct, correct, correct. Yeah, yeah. Ideally, so far, that's
Until
how it
now,
is.
I was thinking we are processing the graph.
No, no,
That's
we are
why
not
I was
doing
saying,
that.
how do we go? I was asking. Okay, that is given and we are going according to that, right?
Correct, correct.
Okay.
So far. Okay. Hope that much is clear. Now I'll share. I think this is okay, right, for everyone, how the processing is happening. I'll stop sharing and re-share the lecture. Okay. Is it visible, guys?
Right? So with a single scan of our text, we can find this pattern. So Knuth-Morris-Pratt algorithm is essentially to compute this automaton efficiently. So remember we said that we only need to look at the last m letters of the text we are scanning to decide, and effectively we're really looking at the last m letters of the pattern, right? We have to match the pattern with itself. If we have matched a certain part of the pattern and the next thing doesn't match, then where back in the pattern are we? So what the Knuth-Morris-Pratt algorithm says is that you actually match P against P itself, right? And it computes this function match, which is defined as follows: match of a position j. So j is going to be between 0 and m minus 1, the positions in my string. The match of 0 of j is going to be the number k if the suffix, the longest suffix, if I take my thing here, right? So this is my pattern, and if I take a j, right? So then if I take 0 to j, so the string from 0 to j is going to be 0 to j plus 1, written as this way in a slide. The string from 0 to j, okay, has a suffix, which corresponds to the prefix 0 to k minus 1. So if I go from 0 to k minus 1 in my pattern, and if I look at this word, it is the same as this word. So that is what match says. So match of j says that if I look at the letters from 0 to j, then the last k letters of this match the first k letters of my string, the string from 0 to k minus 1, the prefix from 0 to k minus 1. So this is what I want to try and compute in this Knuth-Morris-Pratt algorithm. So let's assume that we have done it up to j. Right? So now we want to compute what happens at j plus 1. Right? So we have computed match of j, and match of j is some k. Right? So this is from 0 to k minus 1, and this is from 0 to j. Right? So match of j is k, means that there is a segment of length k here which matches a segment of length k here. Okay? Now I want to extend it. So the good case is that this is actually equal to this. Right? If this is equal to this, then I will just extend the match. Then I will say that if match of j was equal to k, then match of j plus 1 is going to be equal to k plus 1. No problem. But what happens if these don't match? Right? So if I have some letter here which is different from some letter here, which we have indicated by saying they are of different colors, then our goal is to try and find some prefix here which may not be the longest prefix. It might be a shorter suffix, such that if I take the shorter suffix, so if I read off these letters here, then if I look, I will hopefully find an extension here. I will find this orange extension, right? So let me draw this here. So then I will find an orange.
Okay, guys, tell me how much you have understood. Like, we, Uma Subramaniam. Hello, am I audible?
Yeah, yeah. I'm thinking. I think I'm better
Okay.
watching this. This little tougher, yeah. Actually, in that video, we have a numbering. So you go back to the instead of the point is, I will keep on move
Hmm?
forward. The
Hmm.
pattern matching alone move backward. I will never come back. That's the iteration. That's what's my understanding.
Yeah, yeah. So he's just saying about talking about, he still didn't go to the algorithm. I just wanted to like he's just, still talking about the automaton and the stuff like that. Okay.
Yeah.
So I'll tell you what he's explaining here. So the first line is basically the text that we are trying to process. Okay. Is my mouse pointer visible? No, right? I don't think so. It's
It is
visible.
visible. It is visible.
But okay, yeah. So this is the text that we are trying to process, and this is the pattern that we are trying to process. Okay, Uma? Followed? Okay. So he's saying that you have matched from this point till this point. So let's say like you have matched the first four letters of the pattern with the text. Okay. So the fifth letter is if it is not matching, so then he is saying that this is a different letter and this is a different letter. Okay. But that fifth letter could be, you know, um, uh,
In the pattern.
correct, exactly. It could be in the pattern. For
So
example,
start from that. Yeah.
Hello.
yeah, you start from that. That's what he's talking about. Okay.
No. Hello.
Yeah, Nikhil,
This
go ahead.
this is this is different case.
Mm-hmm.
Actually, in this case, we are matching
Actually, it is
pattern
same
with
like a
pattern.
Boyer-Moore.
No, no. It is matching pattern with pattern itself. It is not matching with text. It is
Oh, this
matching
is
pattern
pattern
with
with
pattern
pattern, huh?
itself. Yeah.
Oh, okay, okay.
And then
Oh,
computing match
hmm.
P against itself. And
Ah,
within
okay.
that pattern, we are computing prefixes and suffixes if they are existing.
Yeah, that's correct. That's correct. I missed the point. See, match P against itself. So, Uma,
Yeah. I just remember. It's okay. Loki, move ahead.
go
Actually,
ahead,
the
Nikhil. You
algorithm
want to say
is
something else?
numbered. Yeah, yeah. Actually, when you move forward, you will understand. I now I got it. We will number that pattern because if it is like example A B, we will
Hmm.
number it Gokul. A
Okay.
is one B. It is again the pattern is we are seeing again, right? So this how
Yeah,
we
yeah.
come back and forth. I think we can
Okay.
move forward, then we'll get it. Here at this point, it's very difficult.
Yeah, yeah.
If you
So,
go directly to the
This is
algorithm and what it is getting, then it will be easy, I think.
right? So that's what suggests that we do this. So we initialize this failure to be 0, which means that, remember, we
Nikhil, are you saying at this point?
Yes.
had in that automaton that we built by hand, we said that if we see a letter C which is not at the end of the pattern at any point, then we will go back and reset our prefix that is matched to the empty prefix. So that is the default assumption, that at any point, if I don't find a valid extension, then I will fall back to the empty prefix. So I will just initialize this fail. This fail is just now a function which tells me for every position from 0 to m minus 1, it tells me what will be the, remember that definition, right? So fail of j or match of j is the longest suffix of.
Yeah, Vikram.
Does this matching also include spaces?
Yes.
Yes.
Okay, thank you. This will be very useful for Mad1 project. Thank you.
Okay.
Please continue.
The first j letters which matches the first k letters, right? If it's equal to k. So the default is 0. So now I'm going to run through this. So I'm going to use j to walk through this sequence, and I'm going to use k to keep track of the latest prefix I've seen so far. So k will keep track of the current match, and j will keep track of the next position which I'm trying to update. So in our previous picture, right? So k is this value, and j is telling me where I'm trying to update in this picture. So as we said before, if the value at position j matches the pattern at position k, so I have this prefix up to k minus 1 because I have the value k. I have matched k letters, so 0 to k minus 1 matches 0 to j, right? Or 0 to j minus 1 rather, because I'm trying to update the value at j. So I have matched up to, so I know that in some sense the fail of j minus 1 is equal to k. That's what I tell you. And now you want to tell me what is fail of j. So I said that if this is equal to this, the next position is equal, then I can say fail of j is k plus 1. I increment both. Right? On the other hand, if it is not, then I have to find that longest suffix. But how can I do that? Well, I go back here. Right? It's effectively going back here and asking where should I go backwards. Right? So I take the longest suffix that matches this prefix. Notice that this prefix doesn't include the letter that I had before. Right? So I take, in some sense, a shorter prefix. Right? So I take this prefix up to here. Right? And then I look for the longest prefix suffix there. So that takes me backwards. And then I try again. If it doesn't match, again I go backwards. I keep going backwards so long as I don't hit 0. Right? Once I hit 0, then I just give up and say j equals j plus 1. If I find it before I hit 0, then at that position I will extend it. Right? So this is how it works. So I go backwards and I try to find a shorter prefix that matches. If I do find a shorter prefix, so I go backwards without incrementing j. So I'm still looking at the same j. Right? So I fixed a j, it had a mismatch. I try to find a shorter prefix which matches, so I go backwards. Right? So I find a shorter prefix, check if it matches. So if I can extend that and it is equal to the j I'm looking at now. Otherwise I go backwards again. So there are two.
Does anyone want to discuss something here? No? Okay. Yeah. Anyone? Nikhil, you want to say something?
No, actually, it's hard to explain in words. It's what is happening.
Yeah, exactly. So that's why, I mean, even I thought like he'll give an visible example.
So Gokul, is anyone interested? But Abdul Khan, I don't know. His video is a very good explanation for Ken. I just
Okay, Abdul, I know him. Abdul. Okay. Yeah, even when we were doing it, we were doing the same thing.
yeah, chemical algorithm. He has a table actually, but sir is not showing anything. That's where we are unable to get his lecture.
Hmm.
So of course the J moves and the text just keep on move forward, but only the pattern J move backward and forward. So
Abdul Bari, I believe. Right?
yeah, he teaches very well, very easy
Yeah,
to
yeah.
get.
Do you know that over 90% of the website use JavaScript, making it the language of the internet?
Hi, the topic is KMP algorithm. KMP algorithm is used for pattern matching. If a string is given and a pattern is given, then the problem is to find out whether this pattern is existing inside this string or not. If it is there, then find out its index. Now for this problem, there are various algorithms where KMP is also one of the algorithms. There is also a basic algorithm, naive algorithm. So let us look at how naive algorithm works. Then we can understand the problems or the drawback of naive algorithm. Then we'll see how KMP is better than basic or naive algorithm. Let us see the basic algorithm. See, if there's a string given and we have to find out this pattern, then we will.
Sorry? Do you want to say something?
For he's just saying only naive algorithm. We can move forward to Chem.
So shift the pattern by one step. This is matching. If there is a match, no need to shift. Check the next. That's also matching. And check the next. This is also matching. So yes, a pattern is found inside the string at this place, at this index. That is 4 to 6 index. This example was very simple. I'll take one more example and show you. Now one more example. Here this is a string and the pattern that I have to search is this one. So I have to find out whether there's a match for this pattern in this string or not. So I'll not draw a string and shift it, but instead of that I will take index I and j here. There is a match. So move j as well as I. So I'll just write I and j. They are matching. So move j as I. Again they are matching. Now move j as well as I. There is a mismatch. See, we started this pattern comparing from this position onwards. As I just now said that in the previous example I have shown you that if there is a mismatch, this pattern will move by one step. So there is a mismatch. So again, j will come in the beginning, but what about I? I will start from this place now.
Subramanyam, did you follow? This is the naive algorithm, which we are doing at the start. All right.
So this is the again. There is a mismatch. See, just now we have place. So all the level here, every character will be matched till here, till here. So we learn one thing here that the characters in the string are compared repeatedly. Whenever there is a mismatch, it is shifting I, backtracking I, or moving back I. So this backtracking of I, we want to avoid. Let us see a worst case of basic or naive algorithm. Starting from here, the mismatch J here, then we can find prefix or suffix of a pattern. So what does it mean by prefix of a pattern? We have to take the subset of these alphabets in a pattern, but we must start from the beginning of the pattern only. How many characters I should take in a subset? As many as you want. So I just take A. Okay, yes, it's a prefix. No, I will take A and B also. Yes, this is also a prefix. I want to take A, B, C. Yes, this is also a prefix. I will take A, B, C, D. Yes, this is also a prefix. All these are valid prefix. Then what about suffix? I have to take the subset of this string, but I should start from the right hand side only, right? And as many I want, I can take. So let us start. Can I take C? Just C, yes. Can I take B and C? Yes, B, C. Can I take A, B, C? Yes, A, B, C. Can I take D, A, B, C? Yes, D, A, B, C, and more. But let us stop here. Now the idea of a KMP is that inside this string, is there any prefix same as suffix? Let us see. A, do you find anywhere? No. A, B, A, B, A, B. No, it's not there. A, B, C. Yes, it's there. See, this is matching. So this is the prefix that is also there in suffix. Also there is suffix. So this is the observation what KMP algorithm will do on a pattern to avoid the number of comparisons. Instead of confusing with the prefix and suffix, I'll make it simple. If the beginning part of a pattern is appearing again anywhere else in the pattern or not, that's what we have to observe. I'll take few examples and show you. Let us look at the pattern. And in KMP algorithm, for a pattern, we generate a pi table. That pi is also called as longest prefix, which is same as some suffix, that is LPS. We name it as pi or LPS, whatever the name you like. So how that table is prepared, I will also show you that. Just observe it carefully. Let us take first pattern. A, is it appearing anywhere else? Yes. Oh, B is also appearing. A, B. So this A, B is appearing here also. Then again A, B, again A is appearing here, you see. A as well as B is also appearing. Okay, both are appearing again. So what we do is, we'll prepare a table. We'll write 0, 0, 0, 0. This AB is matching with first and second. As I said, the indices we will start from 1 to onward. So this is matching with 1 and 2. This is not matching. This is matching with 1 and 2. This is not matching. This is the pi table. Now there is an algorithm. I don't want to show you that algorithm. I'm not tracing the algorithm. Simply I'm showing you how to prepare it. If you trace the algorithm, you will get the same results. Next, let us look at this pattern. A, is it appearing anywhere? Yes, it's appearing. Oh, B is also appearing. So this is matching. So this is 1 and 2. Then A anywhere? Yes, it's appearing here. So B, C also appearing. So these three are matching. 1, 2, 3. Rest of them are all zeros. This is a pi table. Now let us check. A, is it appearing anywhere? Here itself. So mark 1. A, is it appearing? Yes, it's appearing. The next alphabet? No, it's not same. A is appearing here. The next alphabet also matching. 2. Then rest all of them are zeros. What?
I believe he made a mistake here, right?
Yeah,
That's what they. Yeah.
yeah, that's
in
main. No, he's going to explain the main part. Yeah.
Correct. Like he has also mentioned it here. See, in P3
Yeah,
B is also matching.
yeah.
Is
No,
everyone
because
able to follow?
actual
Yeah, Uma?
algorithm comes next.
Yeah,
Actually,
yeah.
when he forms the table, we will understand the
I we
second.
have to calculate the prefix and suffix. That's same.
Okay.
What about this? A is appearing here, 1. And this A is also appearing. So from here, if you take, this is matching with this 2. So 2. And these 3 are matching with this 3. So take 3. Then anywhere else, yes, A is appearing here. The next A is also same. So 2. And rest of all the values are zeros. So this is the base of KMP algorithm to prepare the table. Once you prepare the table, the algorithm is simple. Then I will take one example and show you how algorithm works. Let us look at the working of KMP algorithm. My explanation will be based on the tracing of an algorithm. So one thing you have to observe that here in the string, we will not backtrack in the main string. So let us start the working. So this is a pattern. So first of all, prepare a pi table or LPS, so prefix table. A, this is appearing here. So this is 1. The D is also there. So 2. Then the D is not matching here. So not just two alphabets are matching. So take this as 0, this and this all are zeros. So let me put it in a table like this. And also give indices 1, 2, 3, 4, 5. And also I will take one index 0 that will act as a starting point of a pattern. Now let us start. First alphabet, I is there. Then where is J? Now it is not on the first alphabet, we will take it on 0. This is a special thing. You can start from here also, but the working will change a little bit. I'm starting from 0. This is easy. Let us watch. J is on 0, I is on 1, first alphabet. Now compare this string of I with the pattern of J plus 1 being here. Check the next alphabet. They are matching. If they match, then move J as well as I. Now again compare string of I with the pattern of J plus 1, this alphabet. So wherever J is pointing, you try to check the next alphabet. That's B. B is matching here. So take J on the next and I also on the next. Now this J plus 1, yes, this is matching. This is matching J plus 1. So move J as well as I.
So seems like J is telling us until that point you are having a match. Am I wrong?
Yeah, correct. If there's no match, we go back according to the numbering in I
Yeah.
table.
Okay.
Yeah.
So J says that okay, you have a match till this point. Okay. So we are converting, checking I and J plus 1.
We are not moving I, we are just only moving back J. That is the main idea.
Okay. Yeah, we'll look into it.
Now J plus 1 is B and I is B. They are matching. So move J as well as I. Now J plus 1 is not matching with I. So now there is a mismatch. What to do? Observe it carefully. When there is a mismatch with J plus 1 and I, then move J to this index 2. Bring J here. Move it here. This means that this AB is repeating. So AB came 2 times. So already we have checked 1 time. So maybe we have to start from here. So let us observe. Now J plus 1 with this one. Is it matching? No, still there is a mismatch. So again move J to this place. J is here. Now, is it a match with J plus 1? No, still there is a mismatch, but J is on 0, so we cannot move J further, so move I. So in case of mismatch, you observe that only J is moving, I is not backtracking. I has simply moved to the next alphabet. Let us continue. J plus 1 is a match with this I, so move J, move I. J plus 1 B and I is B, match, so move J and move I. J plus 1 and I, C, A, mismatch. So move J to this place, J. And still compare J plus 1, A, and I, mismatch. Now there is a mismatch and even J is at 0. So we cannot move J further on the left. So just move I. Now here's this part you observe carefully. J plus 1, A, I, this is matching. Move J, move I. Just I'll mark here. Now J plus 1 is B and I, they are matching. So move J and move I. J plus 1 is A and I is A, matching. So move J and move I. J plus 1, that is B and I, they are matching. So move J and move I. J plus 1 is a D, but this is A. They are not matching. They are not matching. Then where to move J? At 2. 2. Then again compare. J plus 1, A, match, match. C, AB, AB. So AB, already this portion is AB and this is also there here. So we need not compare that. We can continue from this portion. Here this was a mismatch. You can again start from the beginning. Means we reach till here means this AB have came 2 times. That came 2 times. So one with that one. So move J and move R. Incremented. Now this is the end of a string. Actually this we have reached the end of a pattern. So there is a pattern available inside the string. That's all. This is how KMP algorithm works, or the basic idea behind the KMP algorithm is again compare the characters, right? Avoid the comparison. and don't move I back again like it was happening in basic algorithm. You might have observed that we were moving I only in forward direction. We never backtrack I. Then what is the time complexity of this KMP? See, the size of the string is n and the size of the pattern, if I say m. Then how many times we have gone through this? Only one time. How many alphabets? N. So n is the time taken for parsing through this string. Then for preparing a table, we have parsed through this one. So how many alphabets here? M. So for preparing table M, and for searching a pattern N. This is for a table, that is pi table, and this is for search. So the total time is M plus N. So this is one of the faster.
Yeah, that was really good, right?
Yeah.
Guys, any doubt on that? Anyone want to ask something? Afnan, Subramanyam, Vikram?
No, clear. Let's move on to the next topic.
Correct. Yeah. Fine. So if that is okay, then
So what I was wondering that in our project there are blogs written by different users. So
correct.
we need to compare two blogs and
Hmm.
find people who have similar interests. So this can be used for that, right?
Yes, yes. That's why it was means discovered for pattern matching.
Actually, I have not seen even a single lecture, so I was just wondering. So this is what it is, right? This is why it is used.
Yeah, yes, yes.
Okay, thank you.
Okay. Fine. Fine. So they are asking us which of the following represent the fail function. I mean, sorry, represent the fail function for pattern in the KMP algorithm. So I think this is the table that pi table that he did it. I
Yes,
think,
yes,
right?
yes.
Okay.
Yeah, that's what I also guessed. I hope.
All right. So let's try to complete this by ourselves. All right. So how did we compute the table? Is it possible to insert table in this? Okay, wait. I'll just take my pen. Give me 1 minute. Okay. Great. Here we are. So it's A B A B A C A. Who wanna do this? Someone who doesn't, who really doesn't know it already, but wanna try this. Anyone? Okay. Does everyone know this? How to do this? Vikram, Subramanya, Afnan. I know Umar, Nikhil knows it.
No, I don't know.
Shall we try this, Vikram? If you don't know, we'll try it. Come on. Even I don't know. Just I'm also doing it with you only, right? Even I haven't watched the lecture. So do you remember? So he was taking like A as 0, and if you find A, you put 1. Again you're finding an A, you put 1. Again you're finding an A, you put 1. I believe this is what is happening, right, Uma?
Yeah.
Okay. So then we have AB, right? Oh, okay, but here it's different. Is there a different case for this?
1, 2.
So yeah, this is 0, 0, but we have a AB.
AB we found, so 1, 2, like two text we match. 1, 2.
Okay. Where, yeah? 1, 2 here.
Yeah.
Okay.
And BA 2, 3.
Okay, is it because like ABA and here also ABA, that so we make it as 3?
3.
Yeah.
Okay.
Let's do 0, I think. 1. Okay, that is
So
1.
here this is
0,
1,
1.
0 and
0.
1, and this is also 0.
Yeah.
Okay. So I think this is something new, right? Because ABA you are having something, and earlier it was not like that, right? He used to, used to explain.
So how many texts you are getting in a match method?
Sorry, Uma?
How many texts you are matching inside this pattern itself? We are matching 3, right? A, B,
Yes.
Okay. So that's the reason.
A. Yeah.
Vikram,
Number
is it
of
okay for you?
Yeah, but here A is overlapping.
No, you
Correct.
should not take like that. You should take like a ABA is a text. How many in that text? How many characters? 3 characters. So like that you have to like third one is also matching, like kind of like that.
What is the maximum matching you are saying?
1, 2,
Because
3, right?
BA is also
AB
matching.
means you get only 2. If you're not having that A, you'll get only 2 match, right? But you're having that ABA also. Here also you're
Right.
having it is kind of repeating. So 3 texts your match. Yeah. And see the final one again 1. It starts from 1. Now you are finding only 1 text. So you're assigning as 1.
So if we had another BA at the end, then it will be again 2, 3, right?
Yeah.
Is it?
Yeah.
And again a B. Okay. Would it be 4 then?
Yeah. AB, right?
Correct. Yeah, it will be a 4.
Okay. Okay. Got it.
And if we have an A, it will be again
Because
5.
of this number, it can travel back the J number. That's what he was explaining, no? If this number is there, it shows that how many is matched. We are not counting that. We are counting from the after part of those matching text. That is why we are numbering it.
That AB will be 2. Last AB.
Sorry?
I think that last AB
This one, huh?
will be,
Are you talking about this?
yeah.
Okay, tell me.
The last AB will be again 1, 2.
The thing is, we look at this. We have matched A.
Okay.
So that's what Vikram was asking, right, Vikram?
Yeah. AB, then that will be, but AB at this A, it will be 3.
Which
Last
A?
A. Last A.
Why 3 again? See, we are matching it till this point, right? Look at this.
Yeah.
5,
So
and we are
at
matching
last
5.
A, if sale occurs at last A, then we will move back to that position. No? AB.
Okay. So what are you saying?
1, 2, 3, 4, 5. No, right. 5 is right. Okay. Yes, 5 is okay. Yeah.
Yeah, that's fine.
Yeah.
So let's not. We'll go further. By brute force algorithm. Okay.
Actually,
So
that 5 means when sorry for the interruption, Gokul.
please
That
go
5
ahead.
is in case there is something which is not matching after A. What we do, the J will come to the 5th position. So up to the AB, we will leave and we will start from the next point. That is why that 5 is represented.
Yes.
Correct.
Yeah, that is so it is 5, correct. So we are
5.
going to find match after this AB. That is the
Yeah.
point.
Yeah.
Yeah, Vikram was correct at that point. Yeah. Also. Yeah. So we also saw this also, right? The worst case algorithm for the brute force.
Yeah, it's
Even
really
Abdul was saying, right? So if it is, what is going to be the worst case for this?
The last one, right?
Yeah, something which has all A,
Yes.
right?
Because
Why?
it will match, yeah. First 3 it will match, then it will find it's not matching, and it will only move by 1.
Correct.
So it will be almost n square.
Huh.
Is it? N, sorry, it will be.
I mean, it's a very highly complicated thing, right? You have to do the same computation again and again and again.
Right. Others, maybe you can skip by the length of the word
Correct.
given.
Yeah, that's right. See, others, because see, you have A, first letter and second letter matches. So, I mean, first and first matches, second and second letter doesn't match. So you skip this and go to the third letter, right? So again, I mean, this letter and first letter doesn't match. So you skip and go again. Like, so, you don't need to compute the whole thing again and again. But for the last option, we have to compute till the end of the array, right? End of the string, basically.
Yeah, the second one, I think A will match. Then when the B doesn't match, it will directly jump to the last A. I mean, is it?
What do you mean by last A? No, it will come. I mean, the brute force. We are talking about the brute force.
Okay, brute force. Sorry, I didn't catch that. Yeah, brute force.
See the brute force. Yeah. Okay, good. Fine. We want to search a pattern in the text using the Boyer-Moore skipping heuristics. For which of the following patterns the last dictionary will be the biggest in size? Okay. So Uma, I think we did this right yesterday,
Yeah,
sir.
hypothetic. Yeah, we checked in the code also. Last dictionary will be big for hypothetic because everything is different, no?
Correct.
Yeah, but
So yeah, let's talk till about this to other people. Okay, Subramanyam and Vikram, the afternoon also. So we discussed this yesterday. I'll share you the recording after this. Okay. So what? In order to solve this question, okay. So Boyer-Moore has a dictionary which is called as last. Okay. Which will store the last scene. You know, where was the last time that you saw the particular character? Okay. You followed what I'm saying?
Yes.
Okay, great. So this question is asking us which among the following options, okay, has the biggest size of the dictionary. So how to answer this question is basically the number of unique letters present in that, because that last dictionary will have the keys which are the unique characters. Got the point?
Yes.
Okay. So according to this, hypothesis. Yeah, go ahead, Vikram. Please go ahead, Vikram.
So yeah, so I think here just T is common in hypothetic, right? There is only one alphabet which is common, and rest has more common alphabet. So the length of the dictionary will be maximum with hypothetic.
Correct. So you
Length
can't
of
just say like that. You can't just say like that, but you have to just confirm it also. Okay.
okay.
Yeah. So see, even here if you have automata data. So here the length is bigger, but due to repetitions, the unique characters is less than hypothetic. Got the point?
Yes, yes.
Great. Okay. Fine. So yeah. So here we have the Rabinkov algorithm. What is this about? I think we did this yesterday also. Uma, you want to do it or shall I give it to Vikram?
yeah,
Sorry,
yeah. Yeah, Nikhil also can do.
Nikhil? Yeah. Can you do this question? Answer this question.
Me?
Yeah, you only.
No,
We'll also do it. Huh?
I have not gone through the Rabinkov and Boyer-Moore. I just watched the
KMP.
yeah.
Sure. So I mean, see, it's like that means just Uma only know about this, but
Actually, I am dropping off pdsa this time.
Oh my God, Nikhil, you're so good.
No.
Actually, it is a bad idea coming to the session without watching the lectures. I haven't watched any lectures.
Okay. See, but we are making sure that you understand a little bit out of this. So once you go back to lecture, you will understand a little bit more.
Right.
Right. So if someone doesn't know, we discuss that part. Right. So what is this Rabinkov about? So I'll go to this. Don't feel about without watching lecture coming to the.
Balaji gave Gokul yesterday. Balaji gave a simple example. You remember? At least this question: A is equal to 1, B is equal to 2, and C is equal to 3. If 6 is matching, then it might go wrong also, right? You remember that?
Sorry, repeat.
Hash value.
Take it slow. Take it slow.
Yeah, hash value. We can give
Alright.
we can have our own hash value. A is equal to 1, B is equal to 2,
Correct.
and C is equal to 3.
Yeah.
The total pattern length is 6. So we are checking that whether the text has 6 patterns. But even though 6, but ACB will be distributed as ABC.
Correct.
So then it is wrong. That is what the question is. I just want to remind you that.
Yeah, sure. Okay. So first, let's tell to our friends what this rabbit curve means, right?
Even I want to do that.
Correct. Okay. So Vikram, coming to this point, what Rabinkov basically does is, so it will take a string of numbers, okay, and you search a pattern in that number.
Yeah, matching pattern and return the index where the pattern starts.
Exactly. Okay. So 23, 23, wherever you are having. Okay. That is what the
Yes.
Ravencroft algorithm is. So because if you want to compare 23, right, you don't need to do the whole thing, right? I mean, so here also you are just going to go forward only. You don't need to come back. I'll tell you how. Um, okay. So for example, we'll take that. What was it? 2, 3, 3, 2, 3. Okay, wait. My handwriting is always bad. Okay. This is what is given, and let me increase the size. Okay, Vikram. So, okay. So this is the text. Okay, and the pattern that I'm trying to find out is basically, 23. Okay, and simple. You just take the first two things and you know compare it with this 23, 23. It's a match, right? Then what do? You take 33, and it's just single comparison, even if it is a big number, right? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 5, 6. Okay, so you have such a text, and you're comparing 1, 2, 3, 4, 5, 6. Okay, for numerical comparisons, it is just easy to compare, right? You can, take this 6. I mean, whatever the length of the string is, take that much and compare it. Is it equal to this? If it is equal, then it's a match. You follow what I'm saying, Vikram?
Yes. Then
Right?
you return the index. Yeah.
Correct. Then we return index. Then what do? So we take the next 6 letters, right? I mean, next 6 numbers. So it is not equal. If they are not equal, then it's not a match. Again, you go from 3, 4, 5, 6, and 1, 2. So is it? I mean, 3,45,612. Is it equal to 1,23,456? No. So this is how the Ravencroft algorithm works.
Right.
You got the idea? Okay.
Yes.
Huh.
But this is
So
not the most efficient, right?
sorry.
This is not the
Yeah,
most
this is not the
efficient.
most efficient. Yeah, this is not the most efficient. Uh, this is an algorithm. That's what they are saying. Yeah,
While
and
for comparing the numbers, and Gokul, you forgot to say anything. We are converting this to integer. That is what the algorithm says, right?
correct.
Yeah, we did know, and in the yeah, we have to convert this string into integer. That is what this algorithm is about.
Look at this. In between, we take the index, indices, and do that. Okay, okay. So, Vikram, one more thing that I wanted to tell here is you're having A, B, C. Okay. So what is it? So A, there is something called as hash function. Okay, wherein you give a hash of A equal to 1, hash of B equal to 2, and hash of C equal to 3. Okay, Vikram.
Yes.
Okay, so if I give a pattern like A B C A B B C A B A B. Okay, if I give something like that, then you can simply replace these, right? So 1 2 3 1 2 2 3 1 1, sorry, 1 2 1 2, right? See now the text you have converted to a number, right? You can comparing the number with the pattern is very easy.
Correct.
Right. So that's what it is also trying to do. Okay. And Uma, you want to say something else?
No, Gokul. No, yeah, that
I,
is in the question. It's okay. I think, are you going to the question?
okay, come, let's go to the question. Uma, you answer the question here and explain it to Vikram also.
I don't know whether
Go
I
ahead.
can explain. Okay. If the hash value of a substring of the text matches that of the pattern, then we can guarantee that the pattern has been found in the text. It means the pattern total value is 6. Okay. And we
Okay.
are,
Yeah,
you can
you're
take it,
saying that.
Gokul, yeah.
Repeat.
ACB and something else. You can try initially write ACB. You
Hmm.
can write some BBA or something, extend it. And for
Hmm.
pattern, you take ABC.
Hmm.
So the value of this pattern is 6. And above also the first 3, it is 6.
Sorry, 1 plus 3 plus 2, right?
Yeah. But it is not true because the pattern is ACB, here the pattern is ABC. Just because with the hash value, you cannot guarantee that the pattern exists. We have to go through the actual string. That is what the second line says. Second line is if the hash value of the substring of the text matches that of the pattern, then we have to match the actual substring to the pattern to guarantee that the pattern has been found.
Vikram, did you understand a little bit?
Yes, 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 absolutely.
Okay, go ahead, Uma.
Yeah, this we don't know. It's time complexity. I'm checking that Google in Slack. GitHub. I don't know the time complexity.
So I mean, wait a second. I don't want to give a wrong answer, and I don't want to test myself. Okay,
That's
I'll
true,
go.
I guess. Yeah,
Yeah,
third one is true.
sorry.
The
Means
third,
which
third one is true.
correct? Have same worst case time complexity.
Yeah,
Why is it true?
because it
Yeah,
is
both
when
are
you're
NM.
starting and the string doesn't match, it just skips one alphabet and again starts matching. So
Hmm.
that's why I thought this is not the most efficient way.
Hmm.
That is why I think this is as good as the brute force driving car.
Okay. So you're saying something like I can give a worst case complexity. Worst case.
In fact, now I'm thinking this might be the easiest week of all. Yeah.
Credit goes
Alright.
to Google.
Sorry, Mo?
Credit goes to you because I have to tell Vikram, I haven't watched anything this semester. After watching the whole semester, I only got fail marks, so I decided not to watch. I didn't get understand anything, so I think the credit goes to Gokul.
No. It's all the whole team here, right? It's a good set of people who are coming in. Okay. So okay. I mean, should I explain that? But if it is already done, then fine. So Vikram, can you explain me this third point?
Third one, yeah. So if you are matching
Hmm?
this below string 4 times 1, 2, is it? With the above
Correct.
one.
Yeah, this is what I'm on. This is
So
like this.
1, 1,
Okay.
1, 1 match. So after in the above, we move to this last index and find out that this is not
Hmm.
working, right? So then,
Correct.
instead of moving ahead by 5, we just move to the second index in the
Hmm.
match above string.
Yeah.
So basically, it's checking for everything again.
Hmm. Okay. Okay. Fine. So what about the fourth option?
Fourth, I don't know about
I
Boyer.
think just now I
You
checked.
don't know
I
the Boyer
think both
option.
are N to N. I'm not very sure. Gokul. Both are looks like NM. You can check the notes.
All right. Rabin Corp. No, we're not talking. Are we talking about Rabin Corp? Yeah. Fine. Yeah. For general alphabet, it's NM.
Yeah.
Okay. That's for Rabin Corp. And Boyer yeah, NM.
Yeah.
Okay. So Vikram, if you have a question related to Boyer we'll discuss for sure. Okay. Yeah. Okay. So I think that's okay with these things, right? What about the first option? Why is this wrong?
Because that's how I told you. No.
Oh, that's what we cannot guarantee, right?
Yeah.
Yeah.
It
Okay.
could
Okay.
be
Okay. So first
ACB.
and the second options are like complementary to
I
each
think
other.
that was given by Balaji, actually someone, right? I
Yeah.
remember.
Balaji also. Balaji is here.
Thanks to Balaji. He gave an apt example.
Yeah. Okay. Chalo. We'll go to the next question. Consider the below function that implements Boyer skipping heuristics to find all occurrence of pattern P. Text. Okay. Choose the option in line 17 and line 20. Okay. So how would I tell this? Nikhil, can someone help here? If anyone knows it already, guys. Okay, seems like I'm the one who has to do this. Okay, so Uma, you know about this Boyer-Moore, right?
Yeah, I'm thinking a bit.
So see, nothing. See, if the C is present in the dictionary,
Yeah.
right? So if it is already present, if the character is in the pattern, what are you doing? I plus M minus the last time you saw that
Yeah.
thing. Okay, minus one. So seems like that's okay-ish. But still, we'll do this later at a later period. It's a coding thing, right? It'll take more time, and we just have like 10 minutes. I need to go at 9 o'clock today.
Yeah. Let's move on.
Yeah, let's move on.
That is not
Let's
very
do this.
difficult either.
I said so. If you want, you can answer this.
I cannot thoroughly answer. I don't want to confuse others.
Okay, chalo. Fine. Let's go ahead with this. So Rabin-Corp algorithm using the modulo. Okay, see, okay, find modulo algorithm to match the pattern. Okay, wait. We have Balaji who is an expert at Rabin-Corp. Balaji,
Nothing, no, nothing like that. The Robin Corp.
answer
I'm
this,
not
no?
expert.
Okay, answer this. Can you read the question
Yes.
here?
No.
Read it aloud.
Yeah. Now you have to search the pattern of 36 here. So
Okay.
now if you take a modulo of 11, 36, then the remainder will be 3. So now 3 is whether it now 59 it is there first second 59, that means modulo 59 is 4, so it is not matching, so we can skip. Now 14 will come next. So
Wait,
next
is it
is
91
14.
or 14? Wait, is it 91 or 14?
No,
I
no,
think it's
no.
91.
Okay, 91.
91.
So, 91. So 91 also 88 will come.
3 will
So
get.
88
It means
means
the balance
3.
will be 3. Oh, they're asking us how many
Balance
such
will be.
3 is coming up, right?
Yeah, yeah.
So
False
we have to
positive.
just calculate how many 3 years are coming, how many these things are coming.
Correct.
If
So,
it is
for 91, it is one time, right?
it is one time. Then
Okay.
14 will come second time.
Correct. 14 is also modulo 11 is 3. So we are getting second time. Okay. So 46.
Then 46 will not come.
It is 2. Yeah, it's not come.
So
64.
then 64 also will not come.
It's more than 3 that we can know. We know it won't come. Okay.
So then 42 also will not come.
Correct. 33 and then it's plus 9. Okay.
Then 25 will come.
Correct.
25
So we are
will come.
The third time, right?
Yeah,
Then
third
here
time.
we have 56.
Then 56 will not come. Will not come.
So hence the answer is 3, right?
Yeah.
Okay. So everyone is okay with this, I think, right? Vikram also fine, no?
Yes.
Great, nice. Okay, so coming here, we want to search the pattern strawberry in the text. Strawberry is straw plus berry is strawberry. What is the count of character comparisons using Boyer-Moore skipping heuristics and brute force? How do we do this? Count of character comparisons. Boyer-Moore and brute force. So seems like brute force is having less comparison. Is it so?
I'm also wondering, brute force should have more, no? Because straw is in the first place. I don't know.
Actually, in our case, the options are reversed. 14 and 37 is given.
Repeat. In your case means what do you mean?
Means in our assignments.
Okay.
I
So there
think
is an
are-
updated version of it.
Yes.
If that is the case, then I might have that because I took even not to motivate you guys to take pdsa twice, but yes, I also took it twice.
You gave improvement?
But actually, if you
Yeah, Nikhil. Tell me. Nikhil, tell. You wanted to say something.
No. Actually, I am weak at coding, so I just wanted to practice more. That's why I
Because
dropped.
yeah, because I see The thing is, PDSA is more important, and
Yeah. For the
we
whole
are not
course.
going to study it again. I don't know if we'll get a chance to study it like this with our friends or something like that. I
Yes.
wanted to study it at least to a little bit extent that I know PDSA, at least that much. Okay. So we also have a feedback. Oh, nice. Probably you guys are also having feedback.
Yes.
Yeah.
Yeah. So it's 14 and 37, huh? In this case, like, okay. Now from next time onwards, I need to have both, because see, for the second time they are, they're not giving us the practice assignments, and we don't have a solution for the practice assignments also. Okay. Okay. So shall we do this, Uma?
Yeah. I know
We have
brute force. We can just count until before strawberry for brute force, right?
I want to get the value as 36. You do whatever you want.
No, for brute force. You're asking for Boyer-Moore.
Now, first let's calculate for brute force. All right.
I just calculate all these as front one, right? Because strawberry is only at the end. Brute force go one by one, right?
Yeah.
So we can count the front portion of strawberry.
Okay. So how is it 36? How is that? What is the value?
So
Is
I
it 37? Yeah.
14. Brute force is 14, right?
Brute force is not 14. Right? Brute force is not 14.
No.
Brute
Okay,
force is
sorry.
37. Boyer-Moore is 14.
Okay.
So I want to get the value of 37 for brute force. How do we do that? How many comparisons are we doing? That's the question here.
Sixth comparison will fail, so you shift the entire thing.
Correct. Not entire thing, just one step forward. Right. So I think we are doing five. Okay. Till this point we are checking, right?
Yeah.
Vikram.
Yeah.
Vikram, I also
Yes,
want
Okay.
you to follow.
in
Okay.
straw we are checking brute
Correct. And then
force.
after that we are
Then
having. We
match.
are also checking the what the space also.
Yeah. So
Wait, is there a point like sometimes they used to tell us skip the space? That's what they do. It is not in this question. Okay, so we do 6 comparisons for the first one, right?
right.
0th index 6. Okay. Next,
Then
I'm
we
just writing
do,
the indexes and number of comparisons. Okay. Then
and then we
Then
move
one.
to T,
hmm,
just
Then
one.
only one.
Then from that T, we can directly move
yeah.
till this S and count those.
Okay. So it means here we do one comparison, and then at this point also again one, right? S
One
and R is
comparison.
not matching. Yeah. S and A is not
Then
matching.
till S
W
is
is not.
encountered, all one.
Yes. The
I
space
don't know how
also,
many ones are there, bro.
confusion is the space. Space is also one
Space
comparison.
also included.
Yeah.
Space
Yeah,
also.
yeah.
Okay. S we do one
I
only.
think one is required here, because I think I missed, like, see. So here we have 4, 5, 6, 7, 8. 8 ones is supposed to be here. I think that the characters like that.
Actually, we should write 6 first and then 7, 8, 9 like that.
Oh, you're saying like that? Okay, good. I mean that's a great way. hmm I mean I just wanted to have it come in a proper way. So if I write it 1, 2, 3 and all, so due to the bigger size
No,
of the characters, right? It's
like if
gonna
you write 5, 6 there, or 5,
okay.
or
So
6,
first one it is 6. Okay.
yeah, then 7,
Mhm. Yeah.
8,
We do
like
one comparison, right? 8.
9, you get the answer like in the end.
But still, this is big. I don't want. I mean, I want it to be. I just want to match the above one with the same way.
Yeah.
That's all. 8. Then, sorry, this is 9. Oh my God.
We can go with the 1. We can add it finally. Yeah.
Yeah, 1 also can go. Same thing.
What do you mean, Uma?
Yeah.
No,
Because
the
it's
9
double.
plus can start from 1 plus 1 plus 1 because we can't do 10, 11. No, that's
Yeah, double digit gets confusing.
So
one
it seems like now we'll do we are going on a loop. Okay, so again we start from 1, which means okay, I'll start from 0. This will represent 10.
no, better to put
0 will
1.
represent 1,
Finally,
and
we
again
can
if
add. Finally, we can add as 9 plus 10 plus like that. Better to put 1 Gokul.
okay, one comparison for T, one comparison for fine. Okay, so now we have compared till W, right? Okay. So and for space, I'm giving 1. Okay. Then for P1, L1, U1, right? So for S, it is 2 comparisons, right? We compare S and S, then we have a space and T. So it is 2 comparisons. Correct, Uma?
Yeah.
Now we have space and S, which is 1 comparison. Now B and S, which is again 1 comparison. E and S, 1 comparison. R and S, 1 comparison. R and S, 1 comparison. Y is 1 comparison. Space, 1 comparison. This 1 comparison. In this case, 2 comparison. Space, 1. Here it's gonna be complete comparison. How much is that?
3.
1,
Oh
2,
no.
3, 4, 5, 6,
Completely.
7, 8, 9. So 9 comparisons. Okay. Now 6, 10, 11, 12,
10, no?
13, 14,
9
20.
or 10? Strawberry is 10, no?
Is it so? Okay, fine. Then I'll do a 10. Great. Mhm.
It's coming out as 37 then. Yeah.
Correct. It's coming as 37. Fine. Very good. So we did this. Fine. So now we'll also do it for Boyer-Moore and wind up. Okay. I need to go. Fine. So how do you do the Boyer-Moore? Or shall we continue this tomorrow? I got to go now.
Okay, no problem.
And this.
Yes.
Yeah, it was a nice session today. I mean, don't worry, we'll have more sessions. By the way, but do you guys? I mean, are you guys available in the afternoons or something? How many people are not available?
I'm available whole day.
Who
I
is
am
not
also available.
available? Balaji is also available.
Available.
Okay, nice. Then I mean, just for this week alone, we'll have more sessions and try to cover it up. Okay.
Actually,
Also, the
we
79 sessions.
require
Yeah.
dynamic programming. This
Very good.
dynamic programming is this dynamic programming, no? Something it's so
Yeah.
confusing and all that. That thing has to be there one session
Okay, we'll
because
have more
that
sessions.
only comes pakka for.
Okay. Yeah. So we'll just make sure we prepare it very well for this next pdsa exam. Oh, I mean, in term. All right. Chalo.
Yeah.